Good day to all. Today we are going to discuss the 6 quiz from the lesson chemical processes, the second part, and also non-reactive systems, basic unit functions, and etc. together. So let's get started with the first question. It's the PDF version, by the way, that's why it's shown the questions in this way, but I will also drop down the link for the quiz, and you can also solve the questions and watch the video. The first question is not email. Calculate the single pass conversion around separating sheet unit for expanded polystyrene. So we have some notes here. Let me take a picture. And let's work on the paint together. Okay. Okay. Let's go. The incoming feed, EPS, this one, expanded polystyrene is 125 kilogram per minute. It means this is feed, right? So keep in mind that while solving any questions from the material balance or energy balance topic, you need to look at the sentence one by one. So you need to do your calculation step by step in a wise manner, okay? So for example, it says that our feed is EPS, expanded polystyrene, and its feed amount, the mass flow rate, is 125 kilogram per minute. As you see on the figure, below there are 4 main production units. Let's see what are them. This is pre-expander, first unit. What is that? Intermediate storage, maturing, second one. Production of blocks, if I read it correctly, the third unit. And the last unit is separating sheets. Okay, in pre-expander, the first unit, the feed is lost approximately 15 kilogram per minute. It says that 125 kilogram per minute feed is incoming to the pre-expander and 15 kilogram per minute is lost because of steam. So we are not like interested in the process, how the process is going on there in pre-expander, how the like feed material is lost, but we are we consider only the amount, what amount of, let's say, the EPS is going out from the pre-expander. So if it's 15 kilogram per minute is lost, it means 125 minus 15 is equal to 110 kilogram per minute is the outlet of the pre-expander, right? 110. I will write in this way. Kilogram per minute. Don't forget to write the units. So we have done it the first part. Next, in fluidized bed dryer, this one, the prepared mixture will be sent to the storage for maturing process. So the next step is maturing process. Then this silo material, the silo in this maturing process storage tank, divided into 2 blocks. 2 blocks, as you said. This is like splitter. One stream is out of the silo material. The silo material outlet stream will be split into 2 parts. The above, production of block steam chamber, and the below steam chamber, it's again production of some contour moldings or something. Both of them are production blocks, but the first one is above and the second one is in below. And we say that this is like 2 blocks. One of them is sent to upper steam chamber here. For contour molding, approximately 75 kilogram of minute of this block, 75, is used to make expanded polystyrene. As you see, 110 was incoming to the fluidized bed dryer, then the silo material. Here we say that 75 kilogram per minute of this block used to make expanded polystyrene. It means the final material from this steam chamber upper block will be 75. So then, however, after calculating the EPS weight, it was around 25 kilogram per minute. It says that based on our calculation, it should be 75. However, after expanded polystyrene block, we got 25 kilogram per minute. Next, note that remaining of silo is sent to the below steam chamber here, and the full amount of it's molded into the blocks. So we don't know about the remaining steam chamber in the below section, but it says that there is no loss like in the upper section. Total amount of this steam chamber, total amount of this like molding material silo will be molded part as a separating sheet. So let's see what is the question and how to calculate the problem. So it says that calculate single pass conversion around separating sheets unit for expanded polystyrene. As you see, there are two separating sheets. One of them is EPS, the second one is molded part. Yes. So it's asking a question to calculate this one. So let's also find this one as well. We said that we have 110, the silo material, and 75, it's here, right? This is splitter function. This is 110. One of them is 75, and the remaining is in below section, right? Can we find the below remaining part? I believe yes. The answer is yes. 110 minus 75, it makes 35 kilogram per minute. It means 35 kilogram per minute. It's going to the below steam chamber, and the molded part will be full amount of it, 35 kilogram per minute, because in the question it said that remaining of silo is sent to the below steam chamber and full amount of it is molded into the blocks. Okay. I believe we are done with the calculations. All the numbers, all the variables are known. Now we can solve the problem. It said that in the separating sheets, calculate the single pass conversion. How to do that? We learned in the previous class the single pass conversion, SP, I will write it briefly, conversion. So it's done around one equipment. Inlet to the equipment to equipment minus outlet of equipment. So it can be reactor, it can be distillation column, it can be any separation equipment, it can be purification section or something. It depends on the process. And in the denominator, we write inlet of equipment. Okay, so around the EPS block separating sheets, the incoming feed is 75, as you see, right? And minus 25 is outlet. Yes, 50 was lost. Over 75. It makes 50 over 75, approximately 2 over 3. And when we multiply by 100, it will be approximately 67%. Hopefully it's clear. As I said, it was asked in the question to find the EPS here. The EPS block, we found that the 75 was inlet, 25 was outlet. In order to calculate the single pass conversion, SPC, this is incoming to the process equipment minus outlet of the process equipment over income and multiply by 100%. That's all. Now the second question. Calculate the overall mass flow rate of the molded part unit. So I believe it's asked to find this one. So we found in this way, we said that 110 was after the silo, and it was split into upper part as 75, and the remaining was in the below section. 110 minus 75, it makes 35. So it means we need to write 35 kilogram per minute. Next one. Now find the overall conversion around the plant. In order to calculate the overall conversion, let's remember what was the overall conversion, why it was different from the single pass conversion. Inlet flow rate to the whole unit to plant minus outlet of plant over inlet again. So it means the inlet was 125, right? Let's write it, 125 minus, what was our final product? Final product was 25 kilogram per minute expanded polystyrene block and 35 kilogram per minute molded part. It means I need to take their sum, 25 plus 35 and over again inlet 125. It makes minus 60 over this one. And let's find the percentage with calculator. 65 over 125. This makes 52%. Okay, the answer is 52. How did we do like calculations? The incoming flow rate was 125 minus the outlet. As you see, there are one inlet and two outlets. The outlet was 25, the outlet was 35, and we take the sum of them as 30 we wrote 125 minus 30 over 125 multiplied by 100. It made like 52%. Next question. Select the correct general mass material balance equation. Mark only one oval. Okay. This is called briefly GMBE, material balance equation. The whole concept it was in this way. So let's say we have one again unit. This is inlet. This is outlet, right? Accumulation was the build up or something like accumulated within the system. It was accumulation. In general, material balance equation is shown with the accumulation. Accumulation is equal to, as you say, inlet minus outlet. Hopefully all we are agreed in this way, because inlet is plus always, but outlet is minus. It's something going out from the system. Next, something is generated within the system. It can be byproduct, it can be additional material. It will be plus generated because this is generated within the system. And also consumption, it will be minus sign consumption because the inlet feed materials, raw materials must be consumed in order to generate something, in order to get the outlet products from the system. Our equation will become accumulation is equal to inlet minus outlet plus generation minus consumption. So most of the students, like, they are confusing the whole general material balance equation, but my recommendation is to know about their signs. For example, inlet is always plus, outlet is always minus, generation is always plus. It can be also minus, but most probably you will see like it's plus. Next, consumption is always minus. Then these generated steps, let's say, it will be equal to accumulation. This variant is C. We'll take this one. And also one more thing, most probably in the non-reactive systems, as you know, we'll just revise it. Generation is equal to 0. Consumption is equal to 0. You'll have only inlet and outlet, and their difference you'll be given as accumulation. And also, one more thing, inlet minus outlet, it's equal to like accumulation, but sometimes in batch systems, accumulation is also equal to 0. That's why inlet must be equal to outlet. This, it will be simplest mass balance equation. Next, the sixth question, which variant is correct? Splitter is basic unit function, yes. It just separates the unit into 2 or more divisions, yes, that's correct. So, for example, in the first question, we discussed the splitter in this way. We had one inlet, we had 2 outlets, right? It can be 3, it can be 4, that depends on the system. The thing is that in the splitter, there is no reaction occurring. Therefore, the same compositions in this splitted units will be seen. The first one is correct, note. Separator is a basic unit function, yes. It just separates into the maximum 3 divisions. So most probably it's asked about the distillation column, not separator, because separator, for example, fractionation column, it's also one example for separators. So fractionation column have approximately 10 or 15 outlets. It will be 15 divisions. At each stage, for example, it separates C1, C2, C3, C4, then and it will be going like C70 or C80 like this, bitumen, asphaltene. But if it's about the distillation column, it's right, because we have the top distillate, we have bottoms product, and in some at some point, in some cases, like we have also side product from the middle. That's why it's the maximum 3, but in general 2. The second one is also correct. We are looking for the false one. There is not a difference, the splitter and separator, in terms of the basic unit functions. So the thing is that in the splitter, there is no reaction occurring, and all the streams, they have the same composition. But in the case of distillation column separator, will always have different outlets, different compositions. That's why they are different. I believe it's asked about the false one, false. This will be C. And the next one is mixer. Mixer is a basic unit function, that's correct. Serves for combination let's see, combination, two or more outputs with no reaction. That's correct. Yes, we can have 2, 3, 4 different streams, and it will be given as the one at the end. And also there is no reaction occurring. The main thing, the main aim for mixer is to like prepare the inlet for reactor, for distillation column, for the other units as well. The last variant is also correct. We need to look for the false one. The question, let's say, it was not correct. Most probably it was like checkout. That's why the first, second, and the last one was correct, and the C variant was incorrect. This is not a multiple choice. So let's see. Steam boiler is combination of two equipment. So write down the name of this equipment. In general, steam boiler, they are given as heat exchanger. We have the superheater section in this steam boiler. Also, in some cases, we are using some reactions. And in heat exchanger, we don't have any reaction occurring. But in the case of the reaction must be occurred, therefore, we need to use also additional reactor or furnace. The answer will be heat exchanger and reactor. The next question, which one are given as false for distillation unit? Okay, first of all, the incoming crude oil is sent to fractionation column. That's correct. Why? Because in the last class, we said that in refinery processes, we have, first of all, atmospheric distillation column, or with another name, crude distillation unit. In crude distillation unit, the incoming crude oil will be processed and will be divided into different separated valuable products. The first one is correct. First of all, the incoming crude oil is sent to vacuum distillation unit. This is incorrect because, as we said, the first one is crude distillation unit, fractionation column is itself, CDU briefly, crude distillation unit. The next step, to send these heavy hydrocarbons like asphaltene, bitumen, in order to process them, we are sending them in this shape, the vacuum distillation unit, VDU. In this distillation unit, we have the another additional processing streams, additional process operations. That's why it's different from the atmospheric distillation unit. I want to mention it again. The first one is crude distillation unit or atmospheric distillation column, like this unit. The second one is vacuum distillation unit. The second operation in refiners for light hydrocarbons is vacuum distillation unit. This is also false. Why? Because we said that this is for heavy hydrocarbons, not light hydrocarbons. These light hydrocarbons will be processed as valuable products for the upcoming sections, not in the vacuum distillation unit. This is also false. The below from the feed is called rectification section for distillation column. So let's see one distillation column in this way. And let me change the color. Okay, so above the feed, we'll have enriching section, or let's write rectification. But below the feed, it will be called stripping section. Let's see. The below from the feed is called below. Rectification section, it's not correct because we said this is stripping. The below from the feed is called striving section. No, it's not also correct. To get the desired bottom product we are talking about here, achieved adding steam as utility. So in distillation columns, let me write on paint, it will be more clear to you. New. Let's say we have one distillation column. This is inlet, feed. We have this one. The outlet stream from the above, from the upper section, will be sent to the condenser. And it will be sent to the, after condensing the whole vapor, the reflux drum, like this. And some of them will be go back to the, as a reflux to the system. And the remaining will be sent as distillate. So in order to process this vapor, to condense it totally, we are using additional cooling water. This is GW, this is cooling water, this is utility. Coming to the below part, we have like outlet, it will be sent to the reboiler. Reboiler is something like this. I cannot like draw it very clearly, sorry. Like this. Some of them is again sent back to the system, and some of them will be going out of the system. It will be bottoms product. And additionally, we need to add some, give some heat to the system, and it will be done with the heat, with the help of hot steam. So in order to get the bottoms product, we need to add hot steam. In order to get the above the distillate product, we need to add cooling water as a utility to the condenser. It said that to get the desired bottom product, achieve adding steam as utility. This is correct. Top product, heavy oil as utility. No, we said that this is cooling water. This is not correct. In distillation column, both light and heavy products are present in top and bottom with approximately the same compositions. So it's not also correct, because let's say that your feed is containing like C5, C6, C7, C8. It said in the question that whatever the amount of this C5, 6, 7, 8 in distillate, it will be the same in bottoms. It's not correct, because the light hydrocarbons mainly will be in the distillate and heavy hydrocarbons will be mainly in the bottom product. Maybe you have C8 as 70%, C7 is 20%, and the remaining C5 and C6 together, it will be 10%. But in the above section, C5 and C6 amount, it will be approximately 80%, and C7 and C8, one of them will be 10, 15, and another one will be 5%. As you see, the compositions are always different. Therefore, this is also not correct. The next question. Penicillin is produced by the penicillin fungus at low concentration of glucose. Okay. Therefore, it's essential to periodically add glucose to the reactor to supply the fungus with nutrients. Okay, what type of process is it? In general, we talked about that. So mainly it will be batch or semi-batch. If you are like trying to get as product the pharmaceuticals, it will be mainly the batch or semi-batch. But we are always adding like additional nutrients to the system. In the batch process, we are doing it from the beginning, but in semi-batch, we can also do it in intermittent states. Therefore, the correct answer will be semi-batch process. Let's see if there is any more questions. No, we have done it already. So that's all from today's quiz. We can also revise the previous classes together, and in the next class we'll also discuss the practical questions that we have uploaded last time. It was about the non-reactive systems as well. There were 3 different questions around the distillation column and another purification unit and their equipment. You can also revise that material. If you have any questions, you can ask us in the comment section. That's all. See you in the next quiz.